Charges and isotopes. First of all, we need to define atom, what an atom is. So atom is the smallest particle. An atom's got a neutral charge, or it's got zero charge, because it's got equal number of protons, which are positive, and electrons, which are negative. So these charges cancel each other out. So the overall charge on atom is zero. So what makes atom an atom? So the number of protons decides what type of atom it is. For example, let's just have a look, periodic table. If I'll take an atom with 4 protons, it's going to be beryllium. If I'm going to take an atom with 6 protons, it's going to be carbon. So an atom with 13 protons is going to be aluminium. Okay. So, for example, sodium's got 11 protons, so the atomic proton number is 11. The top number is relative atomic mass. Let's just take a copper. If you have a look, copper's got atomic proton number 29. However, the relative atomic mass is 63.5. I'll just double check in the periodic table. Yeah, it is correct, 63.5. So why is that? Does that mean that we got half of the proton or half of the neutron inside of the nucleus? No, it doesn't mean that. Copper's got 2 isotopes. That means 2 different versions of the same element. So we got a copper 63 and copper 65. But both of them got the same number of proton inside, which is 29. So isotopes are different forms of the same element which have the same number of protons but different number of neutrons. Let's just remind ourselves what an element is. An element is a substance that contains only one type of atoms. Okay, so let's just calculate a relative atomic mass. First of all, we need to know what is relative atomic mass. Relative atomic mass is used instead of the mass number when we are referring to the element as a whole. It takes into the account the different masses and abundances of all isotopes. So it is an average mass of all isotopes. What does it mean, an abundance? That means how often does a certain isotope occur in nature. Okay. So we're going to be using this equation to calculate relative atomic mass, and it is a sum of isotope abundance times isotope mass number divided by sum of abundances of all isotopes, and this number is 100. For example, we're going to try to calculate the relative atomic mass of copper. Copper has 2 isotopes. So the first one is copper 63 and the second one is copper 65. The abundance of the first one is 69.2 and the abundance of the second one is 30.8. So using this equation, we're going to calculate the relative atomic mass of copper. So the abundance of the first one, 69.2 times 63, which is the mass number of the first isotope, plus 30.8, which is the abundance of the second isotopes, times 65, which is the mass number of the second isotope. And we're going to divide it by the sum of all abundances. So 69.2 plus 30.8. Okay, as you notice, the bottom part, it comes up to 100. So we're going to calculate it, and our result is 63.6. Let us check our periodic table. So copper in periodic tables got relative atomic mass of 63.5. So slightly different what we calculated, but it's only because we were calculating to 1 decimal place. If you want to be more accurate, you would need to include more decimal places in your calculation. Okay, there is a time for you to take a chance and try to calculate the relative atomic mass of chlorine. So we got 2 isotopes of chlorine, chlorine 35 and chlorine 37, with abundances for the first one is 75.5 and for the second one is 24.5. Pause the video now and calculate the relative atomic mass using the equation that we introduced before. Okay, so you should calculate that the relative atom mass of chlorine is 35.5. So well done, you calculated that correctly.